Hello there, in this video we're going to be solving the following optimization problem. Find both the dimensions and area of the rectangle of largest area that has two vertices on the x-axis and the other two vertices are on the parabola, as shown in this picture right here. So, the first thing we want to do to solve this problem is notice some things. First off, it's looking for the largest area. And if you know some stuff about optimization problems, that means it's looking for a maximum. So when you do the second derivative test, you want to find a maximum, not a minimum. So that's the first thing we got. It wants specifically the dimensions and the area of this rectangle inside here. So notice first off that it mentions there are two vertices on the parabola, which are referring to this one here and this one here. And notice that specifically their y values are the same, which means when we're actually calculating it, because notice how, like when you find the area of a rectangle, it's going to be the x multiply y, right? The length multiply the height. So in this particular case, we know that both these areas here are the same height. Therefore, we only have to take into consideration one y value. But when you're dealing with the x value, it mentions specifically that it has two vertices on the x-axis. We have one over here and one over here in the negative area. And keep in mind that we don't have any negative y values because they're the same. So when we're multiplying x multiply y, we have to actually do something like 2x multiply y because we have two vertices on the x-axis and they're both going to be, well, opposites and negatives, right? I mean, positives and negatives. And all of this is going to equal our area. So now the next thing we want to do in solving this optimization problem is to have everything in this formula right here be under one variable. And we're going to be using x because it's most convenient. Notice right here it already says, well, y is equal to 12 subtract x squared. So all we have to do then is just substitute this right here in for the y variable, which means a, or the area, is now going to equal 2 multiply x, then multiply 12 subtract x squared, because that's what y is also equal to. So now let's just simplify this a bit, getting 24x subtract 2x, or 2x cubed, all of this equaling the area now. And now that we have this, the next step is to find the first derivative of it. This would be, well, the derivative of 24 is going to be or 24x will be 24. This other one, we put a 3 down there, gives us a negative 6. We subtract 1 from the exponent, and we're going to get a 2. So this is the first derivative of this function we have here. Now what we want to do is solve it for 0 to find all of its critical values. And if we did that, we would get 24 divided by 6, which gives us 4. So we're going to have a 4 on this side. If we put this equal to 0, then add both sides by negative or positive 6x squared. Then you would have a x squared over here. You take the square root, you'll have plus or minus 2 is going to equal x. So these two are our critical points. Now the next step is to actually determine which of these 2 points, the positive 2 or negative 2 for the x value, are going to be the minimum or the maximum. In this question though, notice that it asks for the largest area, which means we want a maximum. The next step then is we have to use the second derivative test to confirm that one of these is a maximum. So we just have to take the derivative again. And if we did that, well, the derivative of 24 is just a 0, and well, so I won't put anything there. The derivative of negative 6x squared will give me negative 12x only. This is the second derivative. Now what we want to do is plug in the values positive 2 and then negative 2 and see if the outputted value is going to be greater than 0 or less than 0. So what happens when we put a positive 2 into this function? Well, negative 2 then a positive 2 here, that's going to give you a number less than 0. What happens when you put a negative 2 in there? It's going to be positive, greater than 0. And whenever for the second derivative test, whenever it's less than 0, you're dealing with something that's concave down. And something that's concave down looks like this. It represents a maximum point, and that's exactly what we're looking for. Whenever it's positive, it's concave up, and it looks like this. That's concave up. So up, and this one's down. Now, which one? Well, the one that gives us a concave down situation, something that's negative, is when we use x equals positive 2. So that's going to be the x value we actually want to use. So now we know that x has to equal 2. But we're not done yet. That just gives us one of the dimensions. We want the y value as well. So if we use the formula we're given right up here, it's 12 subtract and put the 2 inside, 2 squared gives us our y value. That's going to be 8. And now that we have the dimensions, x equaling 2 and 8, or y equaling 8, the next thing we want is to determine, it states the area. Well, using our area formula we have over here, we can figure that out. Just the a value, or area, is going to equal 2, multiply our x value we found, which is 2, then multiply the 8's value, which is the y value, and this gives us 32. 32. So 32 is our area, in 32 units squared or so area, and our individual dimensions are going to be x equaling 1 and y equaling 8. Thank you for watching, and I do hope you're having a fantastic day.